I'm Nick, and this is Raz class. So here I have a controller. This is a Honeywell Spider. It's a unitary controller, which means it's meant to control a piece of equipment, an air handler, a hot water system, chill water system. This is basically a small computer board with control logic written into it. If we open it up, you've got a pretty complex circuitry going on in here. We've also got inputs and outputs are the main component of this controller. It has these terminal blocks here is where we're going to land wires from various sensors that we have out in the field. This is what's going to give feedback to this controller so that it knows what it needs to do on the output side. And through these outputs down here, it's going to be sending out a signal to a device for control. We have digital inputs and outputs. We have analog inputs and outputs. So I have some sensors here to show for example. This one right here is a very basic temperature sensor. This is a probe style sensor. So this is meant to sit on top of ductwork, and this probe will be down in the ductwork to measure the air temperature going through that duct. Very similar but a little different housing style. They have these same type of probe sensors to go into a pipe to read water. It's just going to have a threaded end on this end to spin it in there. So this is what's going to wire back to one of our inputs on our controller, so the controller knows what temperature it's reading there. This right here is a differential pressure sensor. This is going to read air pressure in your ductwork or possibly just in your building to find out the air pressure in your building. Again, this is going to wire back, has these little terminals right here, going to wire back to one of our inputs on our controller. So those are examples of analog sensors because they send a signal that is variable across a scale. The difference between analog would be a digital sensor like this one, which is either going to be on or off. This is what you call a current sensing relay. Power wire goes through the opening here. It reads the amperage going along that wire. And so when it reaches a certain level, which you can set, it will close a relay, which tells our controller that the piece of equipment that we're monitoring is actually running or not. If we send a signal from our output to run a fan, this is what's going to tell us if that fan is or is not running. This is an actuator. These are used to open and close dampers. They have 90 degrees of motion. This example here is a power open spring return actuator is what we call it. When we send power down these wires through the output of our controller, it's going to drive to its open position. When we remove power, there's a spring inside that will bring it back to its normal position. In addition to this style, there are also modulating actuators, which upon receiving power, there's a third wire going to them from an output here, which is generally going to have a 0 to 10 or 2 to 10 volt DC signal, and that's going to tell it how far open to go. 10 volts would be all the way, obviously. 5 volts would be about halfway. This is how we modulate if we need to kind of cut back or open up our airflow or water flow. This U-bolt right here tightens down onto a shaft, and as it spins, it turns the shaft, which in turn turns the damper or a valve open to closed.